Stop worrying about homework and start learning with confidence. This is Ask Learn. Complete help for every subject. Like, share, subscribe for daily learning videos.
So in this question, we have an airplane at 10 kilometers from a radio transmitter receiving the signal intensity of 10 microwatts by meter square. And they want to know what is the amplitude of the electric and magnetic field. So let's do this first. Because we have the intensity, we can find the electric field because the intensity of the electromagnetic wave will be just the amplitude of the electric field square divided by 2 mu 0 c. And we can use this to solve for the electric field component. So this is square root of 2 mu 0 c times the intensity. And we can just substitute values here. This gives us square root of 2 times 4 pi times 10 to the minus 7. This is the electric permittivity. The speed of light, 2.998 times 10 to the 8. And the intensity that we got, 1 times 10 to the minus 6. So everything inside the square root. And this gives us electric amplitude of 8.7 times 10 to the minus 2 volts by meter. Now the second part, they want the magnetic component. So because we have the electric component, we can just find the magnetic component by dividing by C. So this gives us the electric component of 8.7 times 10 to the minus 2 divided by 2.998 times 10 to the 8. And this gives us a magnetic field of 2.9 times 10 to the minus 10 decimal. The last part, they want to know that what is the transmission power assuming that the transmitter radiates uniformly. So because we know the distance that is 10 kilometers that we are receiving and the intensity at that 10 kilometers, we can just write that power is 2 pi r square times intensity. So the intensity falls as r square, the power grows as r square, and we can write this directly as 2 pi times 10 kilometers, so 10 times 10 to the cube square times the intensity. So the intensity is 10 times 10 to the minus 6. And this gives a power at the source of 6.3 times 10 to the 3 watts.